and welcome to Educator.com series on the SAT Math. Today we'll be going over percent on the SAT. The word percent literally means per 100 or a number over 100. So when we're talking about 10% of something, we're talking about 10 over 100 being about the ratio that we're looking at if we're looking at the number itself. So 10% of 20 is really 10 over 100 times 20, and that's because 10% is 10 over 100. If you want to be able to do SAT problems really well and super quickly, it's important that you write all of your percents as fractions so that you don't miss problems that involve tricky decimals, especially when we're looking at maybe 10.7% of something or different decimals in our numbers. The decimal place can get really mixed up if we're just trying to put everything as, oh, 7%. I'll put 0.07. If we just put the number over 100, we're going to get the problems right, no problem. So this is just an important thing to keep in mind. Many types of problems on the SAT test your ability to read the question and translate the word problem into a solvable equation. So you probably have gotten sick of seeing word problems on the SAT if you've gone through and taken some practice tests, or even if you've been watching these videos and have been doing the Learn by Example ones. You've seen that there are a lot more word problems on the SAT than on your standard math test where you just get an equation and you're supposed to solve it or factor it or just deal with the numbers themselves. Word problems come up a lot with percent especially. So you need to know how to use equation equivalent techniques. And what that means is when you see a word, you should know what you're replacing that with. So we already talked about percent, and when we see the word percent, we take the number that we're talking about, so 10%, and we put it over 100. So this word equates to putting the number over 100. The other thing that comes up a lot, especially in really basic percent problems, is if we see the word is, that means equals. Of, so 10% of 20, is really telling us to multiply the two. And finally, when we see the word what, so what number is, what is 10% of 20, we're talking about a variable. The what is what we don't know. So using these, we're going to go over some practice problems together. The other thing, though, that we want to look at before we start going into practice problems is some other ways that percent comes up. So we also see percent in percent increase or decrease problems. And when we're talking about a percent increase or a percent decrease, we're talking about the change in the total or the amount divided by the original amount. So what we want to make sure with these problems when we're talking about a percent increase or decrease is that we have the change in value and not the new value. So if I have a number that goes from 10 to 20, my original value is 10 and my final value is 20, which means that my change is going to be equal to 10, and I find that by taking my final and subtracting my initial from it. So final minus initial is equal to the change. And then if I want to look at percent increase or decrease, I can put the change over the total, so 10 over 10, to find out the percent increase. And I would basically just set this equal to X percent over 100. And here I would be able to quickly see that I actually have a 100% increase and I know it's an increase because I've gone from a smaller number to a larger number. But I would just set it up like this. So change divided by original. And this is going to quickly give me the percent increase or decrease. The other thing that we see come up in this case is when we're looking at interest and discounts. So if we have some sort of interest, we basically have the principal times the rate times the time. So if I have $100 and I'm collecting interest at 5%, if I do this for 2 years, I basically just multiply the principal, so the amount I start with, by the rate, so 5%, which we're always going to write as 5 over 100. And then I multiply that by however many years. So this is simple interest, and we could very quickly solve for the actual interest that we get. The other thing where this comes up is discount amount. So to find the amount that we're discounting something, we take the discount rate times the original amount. So here, if I'm discounting all of my clothes at 20%, I can figure out how much off I'm going to get by multiplying this by the original amount. So if something costs $10 and it's 20% off, I can figure out how much less it's going to be by taking my discount and multiplying it by my original. And then I'll get that I'm going to be able to take $2 off. So on the other case that I'm given the original and the discount, I would be able to find the percent decrease in my price by putting the change in price. So it would end up being $8. It would have changed by $2, and I could put the change in price over the original amount, and I would have 2 over 10, which would correspond to 20 over 100. So I could get that discount rate right back out. So these problems are really percent increase or decrease problems, and all that's happening is that we can be given different information. And these are generally how we see percent increase or decrease in word problems, although occasionally they'll just tell us this is increased to this number, or what is the percent decrease, and then we know automatically what we're looking for. The other thing that comes up is we might be asked about something that's a percent more than or a percent less than. So these are generally the harder SAT questions that you're going to see involving percentages, and they ask questions related to what percent more or less than some previous value something is. Now, these imply a step involving the original amount, which is generally what's not given. So if you have something that's going to be percent more than, what you need to do is take the new value and set it equal to the original value times 100 minus, well, in this case, if we're talking about more, plus more. So the percentage more, if we're talking about something is now 30% more than it started out as, then we put 30 in there and we divide this whole thing by 100. Now, less than, that's the one where we're going to use the subtraction. So new equals original times 100 minus whatever percent less. So here it could also be 20% less than what we originally had, 10% less than, and we also divide this by 100. So we'll look at an example problem of this type of question also. The first example problems, though, are just going to be straight translation problems. So like I said, you just want to know how to convert those words into equations. And these type of problems definitely come up that look almost exactly like what I've written here. So what we do is we take each of the parts and break them down into their equation equivalencies. So here, the number we just bring down. So 16 is, we replace with an equal sign. Here we have 80%. So we're always going to write those as the number and then put this percent as 100. So the number over 100 of, we said, was a multiplier, and then what number? So that's going to be our x. Here I'm going to put a dot so that we can tell that apart from being our x, but multiplier, we can put a dot or a multiplying sign. So here, when we look at these together, then we can easily solve for x just by multiplying this side by 100 to get rid of this 100, because we would multiply both sides by it, and then dividing both sides by 80. And if we did that, we would end up with x equal to 20. And that seems reasonable because we're taking 80% of the number, so less than the entire number, but a relatively good portion of 20, and that's going to end up equaling 16. So like all SAT problems, we want to check for reasonableness, and we can go ahead and check off that problem that that's a pretty reasonable answer. So to go into the next one, here we have 45. We have is again, so we'll put an equal sign there. Here we want to know what percent. So x is our what, and percent always means that we take this number and put it over 100. So 45 is equal to x over 100 of 60. Of means multiply, and here we just put the 60 right in. So again, we have a very easy equation that we can just go ahead and solve. All we have to do is put that x is then going to be equal to 45 divided by 60 times 100, which gives us 75. And we know that this was then 75% if we plugged this number back into the what, which is where we put the x. So we have 45 is 75% of 60. Again, that seems reasonable. For our last question, we have what is 30% of 78? So what x is equals 30% is going to be 30 over 100, and then of times 78. And this one's our easiest type of example. When we already have x by itself, we can just take these two numbers, plug it right into our calculator, and we're going to get that x is equal to 23.4. So that's it for these types of problems. We've basically looked at when we're missing each of the different parts of the problem, and all of them are simple solves as long as we can translate the words right into our equation. So now we're going to look at some more difficult percentages. Our first one, we have Holly, who earns $600 a month acting and $450 a month teaching a theater class. So that means her total per month is going to be $6,000 plus $450. We then know that that's 85% greater than her income 2 years ago. So we're looking at a percentage greater than type problem. And what we're going to try and find is how much total income per month Holly had 2 years ago. So here we can quickly get her income now. It's going to be $6,450. And because we had a percent greater than problem, we want to go ahead and write down our equation for that. So we have then that the new amount is going to be equal to the original amount times 100 plus the percent greater than. So now we have 85% greater than all over 100. And our new amount we have. So given that, the only unknown that we have is the original amount, which happens to be what we're looking for. So we would just plug in 6,450 here, and then we could take this and invert it. So here we would really have 185. If we invert it and multiply, we'll get to cancel out this fraction on this side. So 100 and 100 will cancel, and 185 and 185 will cancel. We multiply the other side by the same thing, and we end up with the original amount equaling the product of these two numbers, which is 3,486 and 49 cents. So if they asked us to round, we would go ahead and round down to just $3,486. Otherwise, we could keep it at this amount. So although this problem isn't quite as easy as just putting the numbers exactly in with is equal to our equal sign and of being our multiplier, this still isn't too difficult of a problem as long as we know this equation. So this one you want to try and know just because these problems do come up. So in this example, we have Kyle, who pays for a dinner out that cost $42 before tax, which is 10%. So our tax rate is 10%. And if Kyle also tips 18% after tax, we want to be able to find the total price of the dinner for Kyle rounded to the nearest cent. So this means we're going to need to find the amount that the tax increases our total by, and then again find the amount that the tip is going to increase our total by after tax. And this will then allow us to find the total price of the dinner. So our original amount, or our original cost, is going to be $42. Now, with this problem, we can really solve it a few different ways. So we could figure out the amount that the tax is going to be, which is going to be 42 times 10%, and then add that to our original. So here we'd have $4.20. If we added it to our original, we'd get $46.20 as being our after-tax amount. We could also look at it as a change. So we're obviously going to change our total amount when we have tax added, and we could do the change over the original, which in this case is $42, is going to be equal to the percent that we change it by, so 10 over 100. And if we do this out with cross multiplication, basically we're going to multiply 42 by 10 and then divide it by 100, which means that our change is going to equal $4.20, which is the same amount that we got here. And in that case, we can also figure out the after-tax amount by doing the same thing, adding the change to the original, and we're going to get $46.20 again. The other option is that we can look at it as a percent more than type problem. And if we are looking for the new amount, so the amount after tax, then we can have it equal the original amount times 100 plus 10, because that's the percent that we're increasing our amount by, over 100. And in this case, when we plug in the original, so $42, and multiply it by what's essentially 110 over 100, or 1.1, we'll just automatically get that the new amount is equal to $46.20. So looking at it this way sort of saves us a step, that is the addition step. But if it makes more sense to you to do it one of these two ways, so just straight up taking a percent or looking at it as a percent change, then you should go about these problems in whatever way you like more. And that's because the thing that's really important, especially in these problems with multiple percentages, so we could have a discount and then tax, or maybe an increase and then some other sort of tax or tip or anything additional. The important thing is just that we keep the numbers straight and we keep what's going on straight. So if you can picture it in your head better as being a percent change, then that's totally fine. The extra step isn't going to take you that much longer. If you can definitely see it as being a percent more than, then this step is going to cut out one of your two steps if you just go through this step only. So this is a really good option. If we do this again, so we got our after-tax amount. If we do it again to get our after-tip amount, we can just put the new amount is going to equal the original, where in this case our original is the after-tax amount, so $46.20 times 100 plus 18, because we're going to increase it by 18% with our tip, and this is going to be 118 over 100, or 1.18. And when we put that into our calculator, we're going to get that the new amount is equal to $54 and 516 hundredths, which is a little bit of a problem because we don't go out this far. So when we're looking at this, we're going to round to 54.52, and that's going to be our total dollar amount. That is what you can expect to see on the SAT for percentage problems. So thank you again for watching Educator.com, and that concludes this video.